Hello, welcome back to yet another video, guys. I'm over 200 videos now, and so I'm getting up there in videos, and I'm just glad everyone is still watching, or at least some people are still watching. Um, we used to get a lot more views, but now it's anywhere between 20 and 50 per video, which is probably half of what it used to be, but that's okay. Um, Anyways, I want to show you guys the Atari Asteroids clone that I'm working on. And so I've been working on this only for maybe a week, maybe 10 days. And there really wasn't that much programming. I sort of got the idea, and then I just went with it. And I did a lot of engineering to this code that I I learned about when I was doing Coco Ultimate way back, and I haven't touched that game in so long. And anyways, I learned this technique while I was making that game, which I haven't finished. The only one I finished was Ghost Saga, and that's on Curtis Boyle's site right now if anybody wants it. The rest of them are still not finished. Tales of Suburbia is very close to finished. But as I was finishing that, I started getting other ideas like I usually do when I did a GIS video, and I'm all over the place, you know. And then I started with the asteroids thing. I was just gonna use one little page on the bottom. Then I decided to go full screen. So let me show you what that looks like. So I decided to go full screen, and as you can see, this is very playable, and I can make it go faster. But for analyzing the game that's not functioning yet, you want to keep it slow so you can analyze things. And I can make this go faster, but if you ask me, this is a pretty good clip for just under 1 megahertz in BASIC. If this was in machine language, it would be full speed. But unfortunately, I don't know machine language. But I'm sure you guys are astonished a little bit, anyways, at the quality of this. So I'm navigating my ship to shoot this asteroid. However, I don't have a projectile programmed in yet. I just got finished with this stage of it about a half an hour ago, not even 15 minutes ago. So I can navigate and clearly shoot this asteroid, okay? So this is in the Vectrex Atari 2600 Asteroids Arcade style. So how am I doing this on a Color Computer 1? We're going to take a little look at the code here, and I always number my codes by 1. So this is only 56 lines of code. To some of you that may be a lot, but to me that's not really a lot. To tell you the truth, I am just astonished that this works at all. Okay, guys, we're not using get and put at all, which speeds things up a lot. We are using draw, and that is it, and p copy, that is it. And I can control the speed of the game by changing variables. And I can speed this up as fast as I want or slow it down as much as I want, even though we're in BASIC. So we're going to go through this code a little bit here. So there's a lot of string activity going on, and depending on what kind of string activity you're doing, you need to clear space. So I cleared 500 and we P-cleared 8, so I can use both screens. I'm going to go through this whole thing. Okay, and then we start off in P mode 4, which is a full screen, and I clear it, and I did issue a screen command, but I got rid of it. Well, you want to do that first so you can see your sprites. We have a border, which is just that border, white border around the screen. Then I have roid $, and I don't need the 1 there. That shouldn't be there because we only have 1 asteroid, 0 counts. Thank you, Curtis, for that tip. I kept that in the back of my mind while I was writing this, and I was hoping that it would work, and it worked. So if you have roid $, there's also a 0. So I'm just using 0s and 1s right now. That shouldn't be there. But anyways, so what I do is I draw an asteroid in a preset boundary in the upper left-hand corner of the screen. I'm working on a 17 by 17 grid for both the asteroid and the ship. And right here is that border. So you actually draw the border and then you fill it in with an asteroid. And I drew one in the style of the Atari Asteroids game. And then I took out the draw command and I set it as a pure string. And I found the center of the square. And what you do is you find the center of the square because you need that for hit detection later on. And then you BM around to get to your start point, which is at the top, and then you start drawing it. So that's the first 10 lines. Now we're going to go through lines 10 through 20. I can't list them all. Let's go through 9 to 15, okay? So now here's the ship sprite. Same thing. I found the center of the screen. P set a point there. I drew a border around it. P set that, a 17 by 17 grid. I drew a ship. And then I got rid of the draw command and set it as a pure string. With, as you can note, there's no color assigned to it. Okay? There was, but I took it out. Okay? So the ship is, it's just, you know, like, I don't know how many people have GPS in their car, but there's that little, like, icon that points you around, and it's a little triangular thing. Here, let's run this again. But that's where I got this from. Okay. It looks like a ship. And whatever, that's what I used. Let's list 9 to 15 again. Then I got to the graphics. So I go sub to 54, which defines BM $, and then it returns and draws BM $1, which I'm using for the ship, and BM $, with no subscription, or BM $0 is for the asteroid. Then I put the color in, then the string, and we're done. Then when I run the program, it's sitting there in the screen there, all right? Then after that, now we're in P mode 4 on this first screen, so we need to copy everything over to the second screen. So we're going to list 14 through 20. So we literally P-copy all the pages over to all the pages on the next screen, and we get rid of the screen command. So once we hit the joystick routine, we're going to go through, I think it's 18 through 28. Can't fit all that on there. Let's list 18 through 23. So now we're in, once we get through that, we get inside past 18, we're in a constant loop from then on in. And we set up the joystick, and then we make sure we're still in P mode 4. Let's list 1 to 10. So we need to reissue that though, because now we're in a new loop. We're in a loop, and this reissue is important because we're going to list 22 through, I don't know, 28, 25, something that will fit, okay? So it's P mode 4 becomes part of the loop. Anything that we do is going to be done on the first screen, but we're only seeing the second screen. So the joystick has 4 command lines: right, left, and up and down. J, 63 is right, J0 is left, K63 is down, and K0 is up. So I'm going to list 26 through 30. We're just going to take a look, and then once we get through that, we'll look at that after. We'll look at the joystick line after, because that's where all the magic happens, just when you move your ship. Then we go sub to 37. So let's list 37. That is when I don't know what this is. What is 37? Let me look at my notes here. 37 is 37 is when our asteroid starts moving. So if we don't touch the joystick, it's going to keep hitting 37 and the asteroid will move. So to demonstrate that, I'm not touching the joystick, but we keep hitting that line, and the asteroid keeps incrementing. I don't know where I was here. So that's 37. It's just we'll go through that after. And so it's bit by bit by bit by bit, and it just keeps cycling. So if I do move the joystick, the ship will move, and then the asteroid will move. If I don't touch the joystick, the asteroid will move and move. And then, so if I hit the joystick, we get a change in the graphics. If we hit line 28 and goes up to 37, we get a change in the graphics. So anytime we get a change in the graphics on screen 1, we need to copy all that information over to screen 2, and then we issue an actual screen command. 4 or 5 handles screen 2 and all these pages, 5, 6, 7, and 8, and then we actually see it. Now, if you note, if you note 21, 22, we don't see this. We go there, we change our graphics, but we don't see it until we get, because there's no screen command, until we get here. That's when we actually see it. Then we go to 18, which starts the whole loop over again. And I want to be, I don't know what I just did here, 1 to 40. It's only 56 lines, so we'll go back into the loop, and the rest of it is just well, it's a little complicated. Let's list 37 to 47 if it'll all fit. We have all sorts of things going on here, and I'm gonna try to break it down a little more. Let's look at a joystick line. Basically, to get the ship to move, if we hit the joystick to the right, we're going to go sub 51, which is going to check the angle of the ship. Then we're going to go sub 54, which is going to check the position of the ship. Then it's going to draw an image of that ship in that position at that angle, but with no color. Then we're going to change the angle of wherever, if we're facing left, down, or up, or we're going to change that angle to right, which is angle 1. They're only angle 0 is the original position. 1, 2, 3 changes it by 45 degrees each time, or I think 90 degrees each time. Just rotates it 90 degrees, I think, 45 degrees. I'm not sure. It just rotates it one rotation. And the reason that I don't have 8, if I run this, I can only change to 4 different positions because of this computer. You can't angle it. You can't get 8 directions because they only allowed for 4. I wish they would have allowed for 8 directions, because now we can't shoot vertically at all. So we have to kind of like get around things and shoot them. I'm not going to take the time to do that manually because it would just take forever. Unfortunately, we only have 4 angles here. So we change to, so it's facing right. Then we increment by 2. Then we do the whole thing over again. We check the angle, the new angle. We check the new BM. And then we draw a ship 2 pixels over with color. And that's how it works. And the same thing for the asteroid. That's all that's happening here. The asteroid is changing angles in a clockwise direction automatically. It's an automaton object. It controls itself. And I'll save that explanation for another video tomorrow because I don't have time to go through all this right now. It's too late, and I'm too tired. I had a long day today. But I'll go through that rest of it tomorrow. And you will be able to shoot a projectile and get rid of that asteroid. But I can put as many on the screen as I want, as few on the screen as I want. I can make them as big and small as I want very easily by using the scale feature, by randomizing where they're coming from, and by changing the trajectory. And the last thing I want to go through is the trajectory. So basically, a lot of people can figure out how to automatize an object, but how do we get it to go on a trajectory by itself? That is another story. So if I can find the line, and it's just a short line. I'm looking at my side notes here. Where do I have it? Define BM $ asteroid. And I see it up here. List 40 to 45. It's 42 to 45. List 42 to 45. It's just actually 2 lines. It's a subroutine. I have it labeled. I have a return statement, and it's 2 lines. So all it is a function. It is a y equals mx plus b function. Everyone should be familiar with this from algebra. If you're not, well, just copy it. You don't really have to understand how it works. I could try to explain it. There's something called define function, DFFN. It's a function, or it's not a command. It's a function, a math function, um, and it's just def fn, and then you name your function. It just meshes together like that. I named it Royd, and then um, you um, you define the variable that you want to use. It can be X or Y. For here it's Y, because if you use a graphing calculator, and I'll get mine out right now, and if you use a graphing calculator, okay, like a TI-84, you go to Y equals at the top, and if you put Y equals 1, what did I do on here? There's no multiplication sign on the calculator. It just multiplies it for you, but here you need to put a multiplication sign. So, and also on this computer, everything's backwards. So if you graph Y equals 1, parentheses X, parentheses plus 0, you'll get a line, a 45-degree angle line from this quadrant all the way up to this quadrant. But when I run this program, it's backwards. It's going from here to here when it should be going from here to here, because we don't have a true Cartesian plane. You can fix that. As a matter of fact, I'll demonstrate that to you. And I haven't gone through the whole thing yet, but if I think if I put let's try parentheses the opposite of the X, something like that. I haven't done this in a long time on this computer. The opposite of X. Now it should be coming from the correct spot, and it's not. It's going, I don't know what it's doing. What is going on here? Let's see what happens. It's all screwed up. That's not working. I don't know. Let's try -1. That's not going to work. I'm just making it worse here. Let's just leave it the way it is. Run that. I'm not going to screw with it right now. It's this computer. It's not this computer, but it's, I don't know if it was 44, 45. Anyway, it's going to be the opposite. You can fix it. I just can't remember how. But on your graphing calculator, whatever you get, it's the same idea. If you go back to Y equals, and if I edit this function, I don't know what's going to happen here. But now if I put, whoops, 1.50, the hell with it. This thing's not going to cooperate with me right now. But you can change the trajectory by changing what you put in the function, but it's not going to cooperate with me right now. But if you use your graphing calculator and you put 1/2 of, I don't know why I'm doing this right now, but it's not going to cooperate with me. But if you do 1/2 x plus 0 and you graph that, you're going to get a line that is flatter. So we can do that without screwing things up. Let's edit 43, and we're going to put point 0.5, and this line will flatten out, or not. I don't know what all these problems are coming from right now, but what is wrong with 38? I'm not even touching 38. I don't know what is going on here. Let me check my y equals again. I don't know what's going on. It should be a flatter line. I think it's going in the wrong direction. So I can't use anything but 1 right now. It should flatten out. But because of where I'm starting it, it's trying to go into territory it should be going more like, instead of 45, it should be cut in half and just come in this way. But because of where I'm starting it, it's going into FC error territory. And that's what the problem is. So I would have to change a bunch of crap that I don't have time for right now. I don't even know where. I don't know. I think if I can find the line, the BM line, list 40 to 45, list 30. Trying to find these lines in here is almost impossible without a list. List 40 to 45. Here it is. Oh, it was right there. It's the next line right underneath it. So let's edit 44 and change this. Instead of 990, let's run that. See, now it's going to start way down here, but it's on the same trajectory, 45 degrees. Now if I edit 42, edit 43, I can put 1.5. It should work. Nope. I don't know why that's not working. Let's try just 0.5. That's not working either. You know, I think because we can't have decimals as the x or something. This should work. I don't know why this isn't working. It should just change the slope of it, but we're going in increments of 1. I don't know. We can't graph a 0.5 of something, which is just going to be troubling. I'll have to find a way around that. But we could graph a 2 of something, and that makes it steeper. So let's go back to 44. Instead of 90, we're going to go back to the top. and we might have to use whole numbers. That makes it steeper. I think we're going to have to stick to whole numbers for some reason. I might have to use other commands, like things I don't remember right now, but there's a way to round the decimal off. I'm going to have to really get into this another time. But if we change this to 3, we're going to get an even steeper angle probably. So now it's almost vertical. I think I'm going to have to stick to whole numbers and just get them coming at you from different directions and try different things. But that's all I have right now. I'm sorry for all the junk at the end. I didn't know the computer is going to give me trouble with this function. But if we list 42 to 44, list 42 to 45, it just basically, if you see down here, when I'm converting it, I use function roid y, and so it does the math, it does the trajectory math up here. It defines it first, what y is going to be. We know what x is going to be. It's just an increment of 1 right now. But y is a diagonal. And so you can't do this with a line statement or anything like that. It has to be done mathematically. So that's how I'm doing it. You put your function here as y, and wherever you want to start it plus that, you know. So if none of this was here, I'd be starting at 9 over and 9 down, the drawing, 9 over and 9 down, which is center of 17 by 17. And then I BM minus it to get to my start point. So we need to have this center, we need to know where it is at all times for hit detection. You want to know where the center of your ship is and where the center of the asteroid is. So when you shoot at it, where it hits you, you define the parameters of distance for when it hits you, or I'm going to use, I could either use distance or peak point for the projectile. So it's just basically substituting all of this in here with just the function roid y. And y is defined as 3 times x plus 0. It should be, and as you change that number, it gets steeper. Or less steep. So that's it for right now. And you can put it equal to anything. If you know calculus or something and you want to have it go on a wave, you can use this as well. This is just linear algebra right here. So basically, if x increments by 1 over, y will increment down. So over positive, down positive, so many. So when x increments 1 over, y will increment 1 times x plus 0, which is equal to x. That's why we're getting that 45 degrees. So 1 over, 1 down, 1 over, 1 down, 1 over, 1 down. That's all it's doing. But when we change this to 2, now it's 2 times x. So 1 over 2 down, 1 over 2 down, 1 over 3 down, 1 over 4 down. So it'll get, you know, less and less steep. And so that's really it. The thing is, you're supposed to be able to use like 0.5 or 1.5 to change the steepness, but on here you can't. I don't know why it's doing that. I swear I've done this before and it worked, and I got it to go in the right direction, but I'm gonna have to figure that out another time on my own. Um, I know there are commands that round the decimal off. I just don't remember what they are, and I really don't think that's gonna help too much, but it could. I don't know. There's a bunch of stuff I have to look at, but just the fact that this is working, and I only had to draw the ship in this position once. That was it. The A is handling all of the changes without. I didn't have to draw this 4 times in 4 different positions. I just drew it once. The joystick changes the angle. Same with the asteroid. I only drew it in one position. The A is changing on its own the position. Because if I had to draw this 4 times in 4 different positions, I never would have got done. But I got this done in like 3 days. 3 days, that's it. It's completely engineered to the point where the computer handles everything. Now, if this had 8 positions, like I wish it did, we'd be able to shoot on a diagonal. And the only way I could do that is by drawing it on a diagonal position and then subscripting A by 2. It would just be a real pain in the ass, so we're only going to use it like this. And I think this is good enough. There's no blinking. We could have tons of asteroids of all different sizes on here, and I could speed it up by changing the increments. And so if I want, just before I let you go, if anyone's interested to show you that, I'm just going to change 22 to 25. We'll find a joystick line. Let's go to the left. Let's change line 25. So the asteroid moves at an increment of 1. My ship moves at an increment of 2. So I'm just a little bit faster than the asteroid. The asteroid is always moving. So if I let go of the joystick, it's going to keep coming at me, so it compensates. But if I want to make the ship go twice as fast as it's going right now, I just changed this one number right there. Now watch how much faster the ship's going to go. Look at it. The ship is going twice as fast as it was going before. So just in this direction, if I changed the increments in the other directions, which I didn't, it would go just as fast in those other directions. So I increased the speed twofold just by doing that. And if I want to really, I'm going to keep this, I'm not going to make it go too fast, because then it just doesn't work right. You don't want it going too fast either. But if I change this to 8 now I went from 2 to 8. So that's, I doubled it. I went from 2 to 4. So I doubled it. And then from 4 to 8, I doubled it again. It's like a 200% increase in speed. See how much faster that is? And I'm almost all the way around this thing now. So that's all you have to do. I'm going to cut this video off right now. And I don't like it going that fast, but I can make the asteroid go fly and everything else a lot faster. But I don't want to do that. I don't want it going super fast. But it can be done without machine language and on and on and on. If you understand your math, you'll be fine. If you don't, then you should learn it. It's not that hard to do, and I'm going to put this back to whatever it was, 2. Let's see. That's it. So this is a good speed right now for analyzing. But when I get the game going, I have to adjust for the number of asteroids on the screen and get the sweet spot for the game, and then the game will play just fine. You don't have to worry about all that other stuff. So if you're a good mathematician, then you really don't have to worry about a lot of nuances. Um, you just have fun with your programs, and I appreciate the continued viewership. And if anybody wants this code, I'm not going to put it in the description yet because I'm not done with it. I'm going to go through the rest of this next time. But that's it for right now. I'll see you guys later. Bye.